Dear friends, it fills me with genuine excitement to walk with you into the universe of neural networks and deep learning, the field where machines learn to mirror the brain's remarkable ability to recognize patterns. These are the stages of the journey we're embarking on together. 1. Data preparation. 2. Model construction. 3. Loss function and optimizer definition. 4. Training. 5. Validation. 6. Model saving. 7. Model loading for inference. 8. Deployment or integration. As in all of our videos, self-development will accompany us along the way. In our previous episodes, we explored how impactful events are registered in the body as memory, profoundly shaping identity and emotional patterning. The body processes trauma through instinctive movement, trembling, posture, and breath. As Peter Levine's research shows, identity shifts when the body completes the movements it once froze. This means that identity does not change solely through cognition, it changes through embodiment. As Pat Ogden explains, identity and belief systems are encoded in posture, gesture, and micro-movement. According to Irmgard Bardanieff, our movement patterns define how we relate both to others and to ourselves. Bessel van der Kolk further emphasizes that identity lives in the tissues and that movement, breath, and awareness can rewrite patterns faster than cognition alone. Our goal in this episode is to guide the body into accepting a new identity. We will focus on how embodiment expresses itself through posture, breath, gesture, pacing, spatial presence, tension, and the way we fall, rise, move, and speak. Datasets, pre-built or custom-made. Our first step is working with data. We can rely on an established dataset or create one from scratch. When using a pre-built dataset, several parameters are essential. Root, the directory where the dataset is stored. Computers require absolute or relative paths. Our nervous system offers similar signals through bodily activation. Does the breath become shallow? Do the shoulders tense? Do we start biting our nails? Train equals true or false, specifies whether the data is used for training or testing. Training occurs when we deliberately acclimate the nervous system to overwhelming emotions. Testing appears when those emotions arise unexpectedly. Download determines whether the dataset should be fetched automatically if missing locally. Transform/target. Transform. Rules applied to inputs and labels. Features are the inputs used to make predictions. Labels are the outputs the model learns to predict. In embodiment terms, features are experiences, and labels are bodily responses. Transforms. In most deep learning tasks, especially image-based ones, we rely on transforms, compose, which chains transformations into a pipeline. We identify the somatic practice we respond to best, dancing, breathwork, sport, or a combination. If we choose dancing, we select music that evokes the desired state and move freely until movement becomes embodied. Normalization, which scales values into a stable range. As Rudolf Laban observed, identity is expressed through movement qualities, sharp or soft, bound or free, rising or sinking. Data augmentation, which artificially expands the dataset during training to increase robustness. As Eugene Gendlin noted, identity emerges through the felt sense, the body's subtle inner knowing. Once the dataset is defined, we use data loaders to batch, shuffle, and load samples efficiently. Next, we specify where computations occur. PyTorch requires clarity about where tensors and models live. Mixing devices causes errors. CPU, the default processor. GPU, optimized for deep learning and significantly faster. In embodiment terms, the GPU represents the state we aim to embody: confidence, grace, presence, while the CPU represents the micro-elements that sustain it: gaze, breath, fascia, and posture. When building a custom dataset, we define 3 essential methods. Init establishes data paths and annotations. This mirrors our vision of the values we aim to embody. Len returns dataset size. Embodiment is not situational. It extends across formal and informal contexts. GetItem retrieves a specific sample. If we aim to embody elegance, does it remain during conflict, or does agitation take over? We divide the dataset into X, inputs, the sketch of our new self; Y, targets, the responses across situations. The network alternates between training mode, like practicing in front of a mirror; evaluation mode, when life presents unanticipated challenges. We define architecture by inheriting from nn.module. Common model families include 1. Sequential models, simple layer stacks. How does a confident person walk or greet? 2. CNNs, spatial pattern detectors. Think body language, gaze, breath rhythm, tone. 3. Transformers, attention-based sequence models. In embodiment, this might mean beginning with shaking out tension, then breath work, then accessible movements. 4. Autoencoders, compression and reconstruction. Embodiment often starts as trying on a character. 5. GANs, generators of realistic outputs. Think of developing a signature gesture, smile, or presence. 6. GNNs, relational models. Some movements naturally pull others into alignment. Within the model, we define layers, activation functions, and learnable parameters. Activation functions introduce nonlinearity. Sigmoid, binary outcomes. Does embodiment require changing everything? Tange, zero-centered. We remove nervous gestures before adding expressive ones. Relu, sparse activation, like softening a rigid facial expression. Leaky relu prevents stagnation. Stretching into a new posture can be uncomfortable. Ji-lu, smooth transitions. Embodiment affects confidence, flexibility, and fitness. Linear, regression outputs, carrying posture consistency across contexts. Within the model, we define layers, activation functions, and learnable parameters. Activation functions introduce nonlinearity. Sigmoid, binary outcomes. Does embodiment require changing everything? Tange, zero-centered. We remove nervous gestures before adding expressive ones. Relu, sparse activation, like softening a rigid facial expression. Leaky relu prevents stagnation. Stretching into a new posture can be uncomfortable. Ji-lu, smooth transitions. Embodiment affects confidence, flexibility, and fitness. Linear, regression outputs, carrying posture consistency across contexts. A single training step typically includes 1. Optimizer.0 grad. Clears previous gradients, similar to releasing outdated priorities or gestures we no longer identify with. Second loss, backward. Computes how parameters should shift. Even if the old self enters the room, posture can be adjusted the moment awareness arises. 3. Optimizer. Step. Applies the updates, integrating behaviors that align with the desired identity. Common optimizers include SGD, simple and reliable, like evaluating which aspects of old body language no longer belong in the next chapter. SGD with momentum, smoother learning, similar to starting with the easiest embodiment changes. Atom, adaptive and widely used, ideal when the identity we are forming is still blurry or multifaceted. RMS prop, suited for unstable or fluctuating patterns, like embodying a new self while residual tension remains in the body. Adagrad, Ada delta, effective for sparse features, such as rebuilding identity after major life events. To track progress during training, we often use TQDM, which displays loss, accuracy, and timing across epochs. Over time, the model refines its parameters, evaluates outcomes, and stabilizes learning. To prevent overfitting or instability, we apply regularization techniques. Dropout randomly disables neurons during training. Embodiment should feel natural rather than forced. Occasional slips do not negate integration. Early stopping halts training when performance stops improving on validation data. Just as we learn to recognize postures or attitudes that no longer belong to our identity. Weight decay discourages overly complex models, guiding them toward simplicity and coherence. Aim for whole body harmony rather than rigidly correcting a single detail. Calling model.train places the network in learning mode. In this state, dropout randomly deactivates neurons. Batch norm uses statistics computed from the current batch. Each training iteration follows these steps. 1. Enable training mode. 2. Reset gradients with optimizer.0grad. Similar to noticing when an old habit resurfaces, such as frowning while listening. 3. Run the forward pass, forming new associations between actions and meaning. As Antonio Damasio notes, identity is constructed from bodily sensations. The emotional meaning we assign to movement shapes our narrative. 4. Compute the loss, measuring the gap between predictions and targets. Residual nervous system tension may still make embodiment feel artificial. 5. Execute backpropagation, adjusting parameters so change remains tolerable and organic. 6. Update parameters with optimizer.step. What once felt foreign begins to feel natural. Throughout this process, TQDM visualizes learning dynamics across steps and epochs. For evaluation and inference, we switch the model to model.eval. This disables stochastic behaviors such as dropout and stabilizes batch norm. We also wrap inference in torch.nograd open parenthesis to prevent unnecessary gradient computation and reduce memory usage. Evaluation metrics include classification, accuracy, the proportion of correct predictions. Does the embodied self match the intended image? Precision, how many positive predictions were truly correct? Is relaxed confidence more effective than forced authority? Recall, sensitivity, how well relevant cases are identified? Have we anticipated embodiment across all contexts? F1 score, the harmonic mean of precision and recall, useful for imbalanced datasets. Regression, RMSE, penalizes large errors, such as exaggerated or theatrical embodiment mistaken for authenticity. MAE averages absolute errors, like maintaining posture only in public rather than integrating it fully. Intersection over union, IOU, measures overlap between predicted and actual regions. Are we embodying calm only in specific settings or consistently? Blue score evaluates translation quality. Noticing a slouched moment does not erase overall progress. Once training is complete, we save the learned parameters. This preserves learned patterns so they can be reused without retraining. At this stage, the model is fully prepared to generate predictions on unseen data. In human terms, this is where embodiment is tested by real life. The question becomes, does the new identity hold under unfamiliar circumstances, or does the system revert to old defaults? This is where integration reveals itself, not in practice, but in lived experience.